Hello again, everyone. I hope you're doing well, and thanks once again for watching this video. This one is about the unit circle, obviously, and I'm going to talk about three little aspects of the unit circle. The first one is just evaluating a trig function, which is kind of the basic purpose that we have the unit circle around for. It's a great device for that. But it also serves as a good way to explain a couple of things like what are negative angles, and this idea of coterminal angles will also be talked about here in this video. Okay? Before we get started on these topics, though, I wanted to just mention that this symbol that we see a lot in our trigonometry, that's the Greek letter theta, and for some reason, I don't really know why, but for some reason that variable is the variable of choice to represent any angle. Okay, so you'll see it over and over again. It just means some angle. Alrighty, so let's take a look here at evaluating a trig function. And I've got the first quadrant of the unit circle there, and I've just picked out 60 degrees, or pi over 3. And you, just like on your unit circle, you have the x and y coordinates there, 1/2 and root 3 over 2. Now, to evaluate a trig function, all that means is to kind of name what the sine or what the cosine of that angle is. All right, and to do this, all you have to remember is that the x-coordinate there on the point represents the cosine of the angle theta, and the y-coordinate represents the sine of theta. So it's that simple, really. Those x and y coordinates, which you have on your unit circle and which follow a very symmetrical pattern all the way around the circle as it goes through the 4 quadrants of our xy plane. Those numbers represent the sine and the cosine of all these different angles going around the circle. So it's quite simple, really. There, calling that angle theta there, cosine of pi over 3 is equal to 1/2. That's all it is. The x-coordinate of that point. The sine is equal to root 3 over 2. And that's really all it takes to evaluate a trig function. Now, if you have to use the tangent or secant or cotangent or something like that, one of those other trig functions, there may be a little bit more work involved, but probably not too much. Okay? All right, so let's take a look at our next little topic here, which is about negative angles, what that means. And just to remind you, here's the unit circle there. I've got quadrant 1, well, most of it anyway, and quadrant 4. And let's go ahead and put in some values there like you have on yours. There's your angles, and we have established already that starting with 0 there on the positive x-axis, these angles are measured in the counterclockwise direction, and that is the positive direction. So it makes sense then that the negative direction is just going the opposite way around the circle, clockwise, as a matter of fact. And there's negative pi over 6, negative pi over 4, etc. Now you probably have on your unit circle, you probably have this angle here as 11 pi over 6. And that's right, that angle 11 pi over 6 and negative pi over 6 are at the same place on the unit circle. They're not the same number, clearly they're not the same number, but they are at the same place on the unit circle. And they have the same x and y coordinates as you go around the circle. So negative pi over 6 and positive 11 pi over 6 are at the same place, and they use the same x and y coordinates, which means they have the same sine and cosine. The cosine of negative pi over 6 is root 3 over 2, just like the cosine of 11 pi over 6 is root 3 over 2. And same with the sine of negative pi over 6. Okay, it's the same as the sine of 11 pi over 6. And so I just thrown in here the sine and cosine of those other angles there, just to show you that evaluating a negative angle is really no different than evaluating a positive angle once you locate the angle. So sometimes that might be a little bit of a challenge if it was negative, 5 pi thirds or something like that. You may have to stop and think about that, for example, where exactly that is. But once you figure out where the angle is, the sine and the cosine, it's just those x and y coordinates at that point. Okay? Well, I hope that helps a little bit with negative angles. Let's talk about coterminal angles next, but just let me point out here that these two angles right here 11 pi over 6 and positive pi, and 11 pi over 6 and negative pi over 6. Those are two different angles and the same place on the unit circle. As a matter of fact, that is the definition of coterminal angles. Angles with different measure, but the same location on the unit circle. Okay? So that's what they are. There's a really important and useful little fact about coterminal angles, and that is that the numerical difference between them, okay, the actual numerical difference between any pair of coterminal angles is always a multiple of 2 pi. So that makes it easy to find other coterminal angles if you're given an angle. So let's try that. Let's say we've got the angle 2 pi thirds, and there's a little sketch of it on the unit circle. Now, if I just were to go around the circle one more time, okay, that would be just like adding 2 pi. Okay, once around the circle is 2 pi. So if I have 2 pi thirds and I go around the circle an extra time, then that's just like adding 2 pi. And if you add 2 pi thirds plus 2 pi, what you get is 8 pi thirds. So that number, or that angle, 8 pi thirds, is actually at the same place on the unit circle as 2 pi thirds. And so those two angles are coterminal angles. And I could add another multiple of 2 pi, like 4 pi, and that would give me 14 pi thirds. And all three of those angles are coterminal angles. I could even subtract 2 pi. If I took 2 pi thirds and subtracted 2 pi, I'd end up with 4 pi thirds, another coterminal angle. So I could keep going around and around and around the circle, you know, lots of different times. I could go either the positive direction or the negative direction, and I would still be at that same place around the circle. Now, that 13 pi over 2 that just popped over there on the right side, that's there because sometimes you are given an angle, and your job is to figure out what the other coterminal angles are. Especially, you want to find one maybe that's below 2 pi, between 0 and 2 pi. So the way to do that is to just start subtracting 2 pi. So that's like subtracting rotations around the circle. So if you subtract 2 pi from that, what you get is 9 pi over 2. If you keep on subtracting 2 pi, you'd get 5 pi over 2 and then pi over 2. And all of those are coterminal angles with 13 pi over 2. So all you have to do is subtract multiples of 2 pi from something to find another coterminal angle. And that's really all there is to that. Well, this video had a lot of stuff in it. I hope it didn't go by too fast. Please feel free to come back and check it out again if you're getting unsure about anything that you run into. All right, thanks. Bye-bye.